Assalamualaikum Doktor, my name is Nur Akila binti Muhammad. My matric number is 286905. So today I'm excited to share with you a fundamental concept in economic, which is substitution and elimination. We will explore how price and quantity equilibrium can be expressed through the substitution and elimination equation. So I'm going to answer question number 1, which is Q equal to A minus BP, Q equal to negative C plus D times P minus T. To refresh our memories, let's recall the substitution equation. Substitution equation is QD equal to QS. This equation derived from the economics model and represent the equilibrium quantity. Now let's see how we can express in terms of other variables. So QD is A minus BP and QS negative C plus D times P minus T. Let's simplify this equation step by step. A minus BP equal to negative C plus DP minus DT. We need to rearrange the terms, then it will be DP plus BP equal to A plus C plus DT. Then factoring out P, so it will be P times B plus D equal to A plus C plus DT. This brings us to an interesting expression for P star. Here P star represents the equilibrium. So next we will use elimination technique. The elimination equation is QD minus QS equal to 0. Expressed in terms of variable, it will be BP minus bracket minus C plus D times P minus T equal to 0. Then remove the bracket and it will be A minus BP plus C minus DP plus DT equal to 0. After a few steps, we will get same answer with the substitution. Then we need to find quantity equilibrium. So substitute the price equilibrium into first equation, which is Q equal to A minus BP. Then replace P with the P star that we get before. Then turn to Q equal to A minus B times A plus C plus DT divided by B plus D. Then after a few steps, we will get the final answer, which is Q star equal to AD minus BC minus BDT divided by B plus D. So for the next question, which is 1B, is P equal to negative Q square minus 3Q plus 20 and P equal to 3 square minus 10Q plus 5. First step, use substitution equation. So it will be negative Q square minus 3Q plus 20 equal to 3Q square minus 10Q plus 5. Bring this Q to the left and even number to the right. Then it will be negative Q square minus 3Q square minus 3Q minus 10Q equal to 5 minus 20. Then solve it until we get the answer, which is negative 4Q square plus 7Q plus 15 equal to 0. Then factor in the quadratic equation and we will get Q minus 3 and 4Q plus 5 equal to 0. This gives a potential solution for Q star. The factorial form suggests two potential solutions, which is Q star 3 or Q star negative 5 divided by 4, but we need to reject the second Q star because it is not valid quantity. So the valid equilibrium quantity is 3. For elimination technique, turn the first and second equation into QD minus QS equal to 0. It will be negative Q square minus 3Q plus 20 minus positive 3Q square plus 10 minus 5 equal to 0. After solve it, we will get negative 4Q square plus 7Q plus 15 equal to 0. Then factor the quadratic equation and the answer we will get same like substitution, which is Q star 3 and Q star negative 5. After get quantity equilibrium, we need to find price equilibrium, which is P star. So substitute Q star into first equation, which is P equal to Q square minus 3Q plus 20. Then we replace Q with the Q star. The equation for P will turn to 3 square minus 3 times 3 plus 20. After solve it, the price equilibrium will be 2.
My name is Nurul Amirah. Matric number 295217. I will present the question number 1C. Question given to find the value of choice variable using both substitution and elimination. given QD1 equal to 10 minus 2P1 plus P2 plus P3. QS1 equal to negative 1 plus 8P. QD2 equal to 20 plus P1 minus 2P2. QS2 equal to negative 2 plus 6P. QD3 equal to 15 plus 3P1 minus 2P3 and QS3 equal to negative 6 plus 3P. First of all, we need to using the equilibrium condition QD minus QS equal to 0. For QD1 minus QS1 equal to 0, 10 minus 2P1 plus P2 plus P3 minus negative 1 plus 8P equal to 0. 10 minus 2P1 plus P2 plus P3 plus 1 minus 8P1 equal to 0. We get 11 minus 10P1 plus P2 plus P3 equal to 0. For QD2 minus QS2 equal to 0, 20 plus P1 minus 2P2 minus negative 2 plus 6P2 equal to 0. 20 plus P1 minus 2P2 plus 2 plus 6P2 minus equal to 0. We get 22 plus P1 minus 8P2. For QD3 minus QS3 equal to 0, 15 plus 3P1 minus 2P3 minus negative 6 plus 3P3 equal to 0. 15 plus 3P1 minus 2P3 plus 6 minus 3P3 equal to 0. We get 21 plus 3P1 minus 5P3 equal to 0. Using the substitution technique, get P1 from 2. 22 plus P1 minus 8P2 equal to 0. P1 equal to 8P2 minus 22 for number 4. Next, sub 4 into 1. 11 minus 10. 8P2 minus 22 plus P2 plus P3 equal to 0. Plus 11 minus 80P2 plus 2 to 0 plus P2 plus P3 equal to 0. We get 231 minus 79P2 plus P3 equal to 0 for number 5. Next, sub 4 into 3 to get 6. 21 plus 3, 8P2 minus 22 minus 5P3 equal to 0 plus 21 plus 24P2 minus 66 minus 5P3 equal to 0. And we get negative 45 plus 24P2 minus 5P3 equal to 0 for number 6. Next step is answer for 5. We need to divide 5 to eliminate P3 and get P2. 1155 minus 395P2 plus 5P3 equal to 0 minus negative 45 plus 24P2 minus 5P3 equal to 0, and you get 1110 minus 371P2 equal to 0. P2 equal to negative 1110 divide negative 371, and we get P2 star equal to 2.99. Last step is P2 star into 4. P1 equal to 8. 2.99 minus 22. We get P1 star equal to 1.92. Next, using the elimination technique. Using 1 and 2 eliminate P1. 2 times 10 equal to 4. 11 minus 10P1 plus P2 plus P3 equal to 0 plus 2 to 0 plus 10P1 minus 18P2 equal to 0. Get 231 plus 19P2 plus P3 equal to 0. Next step is 1 and 3 to eliminate P1. 1 times 3 and 3 times 10 to eliminate P1. 33 minus 13P1 plus 3P2 plus 3P3 equal to 0. Plus 210 plus 13p1 minus 14p3 equal to 0. Get 243 plus 3p2 minus 47p3 equal to 0. Next step is 4 and 5 to get p2. 4 times 47 to get p2. 10857 minus 3713p2 plus 47p3 equal to 0 plus 243 plus 3p2 minus 24p3 equal to 0. Get 11100 minus 3710p2 equal to 0. p2 negative 11100 divide 3710 get p star equal to 2.99. Let's substitute p2 star into 4 to get p1. p1 equal to 8, 2.99 minus 22 get p1 star equal to 1.92. That's all from me.
My name is Yokashian and my metric number is 293308. I would like to present about question number 2. Given that the function of a demand is a minus bp squared, a and b greater than 0, and the function of supply is negative c plus dp, c and d greater than 0. So the question 1 asks that what is the meaning of the given restriction. Since negative value for parameters could not make acceptable in the context of a market model, this is a typical assumption in economic model. For instance, the related quantities, price, and correlation must all be positive. Next, the question asks that why the equation above are called behaviorable equation. The equation generally describe a function based on hypotheses are referred to as behavioral equation because they describe a subjective relationship between seller and consumer as they react to change in the good and price level. The next question asks that what form or version of this partial market model presented and justified. The market model that is being provided here is a function that considers a single market with a single price and quantity. It is a partial equilibrium model with a linear supply and non-linear demand. And the last question about question 2 is to make the model meaningful in the economic sense, what assumptions should be placed on the value of both Q and P? The assumption is both Q and P must be positive value.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Fahira Bisaidi. My number metric is 293810. For question number 2, 5 Raman, explain why metric approach is not applicable here. So the answer is the given equation are not in matrix form. So the metric approach is applicable in system of linear equation where the coefficient of variable. And then the next question is find the value of endogenous variable using both substitution and elimination technique. For substitution technique, we use QD equal to QS. Then we enter A minus B P power of 2 equal to negative C plus DP. For solution for X, negative B plus minus square root of D power of 2 minus 4AC per 2A. And then we will make a solution for P. We use the quadratic formula negative D plus minus square root of D2 minus 4 multiplied by B and negative A minus C per 2 multiplied by B. And then we make a solution for P star negative D plus minus square root of D2 plus 4AB plus 4BC per 2B. And then for Q star negative C plus DP. For P star, we include that negative C plus D. And then we multiply by negative D plus minus square root of D power of 2 plus AB plus BC per 2B. And then solution for Q star is negative 2 BC plus D multiplied by negative D plus square root of D2 D power of 2 plus 4AB plus 4AC per 2B. For elimination technique, we use formula QD equal to QS equal to 0. So we enter that A minus B P power of 2 minus C plus DP equal to 0. And then we rearrange it by B P power of 2 plus DP minus A minus C equal to 0. And then for X, we use that negative B plus minus square root of D2 minus 4AC per 2A. For P, we use quadratic formula negative D plus minus square root of D power of 2 negative 4 multiplied by B and negative A minus C per 2B, and P star is negative D plus minus square root of D2 plus 4AB plus 4BC per 2B.
For question 3, given that y equal to c plus I null plus g null, c equal to c null plus byd, I equal to I null, g equal to g null, and t equal to t null plus ty. Using reduced form, find the value of endogenous variable. The endogenous variable for this equation is y, c, and t. First, we need to substitute equation c into equation y, which is y equal to c null plus byd plus I null plus g null. Next, we expand the byd term become b y minus t and substitute the t into it and solve it. After we solve it, we will get the value of endogenous y is c null minus bt null plus I null plus g null divided by 1 minus b plus bt. After that, to find the value of endogenous t, we substitute the value of y into the t equation, which is t equal to t null plus t times c null minus bt null plus I null plus g null divided by 1 minus b plus bt, which is value of y. After we solve it, we will get the value of endogenous t is t null minus bt null plus tc null plus ti null plus tg null divided by 1 minus b plus bt. Next, to find the value of endogenous c, we substitute value of y and t into the equation of c, which is c equal to c null plus b times y minus t, and it will become c equal to c null plus b times c null minus bt null plus I null plus g null divided by 1 minus b plus bt minus 2 bt null plus tc null plus ti null plus tg null divided by 1 minus b plus bt. After solve it, we will get c null plus bi null plus bg null minus bt null minus bti null minus btg null divided by 1 minus b plus bt for value of c.
Assalamualaikum, my name is Nur Amisha Fazira binti Samri, matric number 295162. I will be presenting the next question 3.2. Given the following information, C naught equal to 10, I naught equal to 20, G naught equal to 20, T naught equal to 10, B equal to 0.8, and T equal to 0.25. Calculate the endogenous variable. So, to calculate the endogenous variable, we need to substitute the given value into equation y, c, and t that we obtained from reduced form calculation, which is y equal to c null minus b t null plus I null plus g null over 1 minus b plus bt equal to 10 minus 0.8 times 10 plus 20 plus 20 over 1 minus 0.8 plus 0.8 times 0.25. Solve it and we will get 105 for y. Let's substitute the same given value into equation t. T equal to T null minus B T null plus T C null plus T I null plus T G null over 1 minus B plus BT equal to 10 minus 0.8 times 10 plus 0.25 times 10 plus 0.25 times 20 plus 0.25 times 20 over 1 minus 0.8 plus 0.8 times 0.25, and we will have 36.25 as T. Last but not least, substitute the given value into equation C. C equal to C null plus B I null plus B G null minus B T null minus B T I null minus B T G null over Y minus B plus B T. we will get 10 plus 0.8 times 20 plus 0.8 times 20 minus 0.8 times 10 minus 0.8 times 0.25 times 20 minus 0.8 times 0.25 times 20 plus 1 minus 0.8 plus 0.8 times 0.25 and C will be 65.